Building a gaming PC for the first time can be a pretty steep learning curve. With so many part choices out there, it can be tricky to know which ones to pick and what crucial mistakes to avoid along the way. And that's why today I'll be covering off everything that you need to know about building a gaming PC in 2023. From the basic parts that make any build possible to everything you need to know about each of them. I'll also be recommending some of my favourite components a bit later on to help you guys build the best gaming PC you can without wasting any money. Let's do this. Every gaming PC is comprised of at least 8 core components. Higher end builds may feature optional extras, but the 8 components are constant, regardless of how much you spend. I'll be running through in detail all of the things you need to know about these 8 components, and you can skip through using the timestamps below. These 8 components are the CPU, or the processor, a cooler for the CPU or processor, your motherboard, which is what's going to connect all of the parts together and provide the bulk of connectivity in your build, the RAM, or the memory. This is going to be the memory used by your CPU to store all of your game and application data, some form of long-term storage, such as an SSD or a hard drive, the graphics card, which is going to deal with all the gaming predominant applications, the case, which houses all of the components, and the power supply, which will give everything power. Let me begin by looking at the CPU first of all, and then I'll work through that list one by one. Now, when it comes to processors, there are 2 main players in the market, AMD and Intel. When I say there are 2 main players, they're basically the only 2 players. The CPU market is one of the most famous duopolies in the world, whereby 2 people dominate the whole thing, at least on the desktop side. In order to best understand the CPU market, we first need to look at how the naming schemes are structured for each of these processor lineups. AMD have their Ryzen 3, Ryzen 5, Ryzen 7, and Ryzen 9. The higher the number, the higher end the CPU, while Intel have the i3, i5, i7, and i9 ranges. Once again, with Intel, the higher the number, the higher end the processor. Following this, you'll also then have a further number, which indicates a few things. First is the CPU generation. If your CPU on the AMD side starts with a 7, it's in AMD's latest 7000 series. On the Intel side, the newest chips start with the number 13, indicating the 13th generation. The number that then follows indicates just how high-end the CPU is. For example, Intel's 13400 chip is a cheaper and lower power chip than their 13600. The bigger the number, the more power. You'll also see a couple of numbers and letters at the end of some chips. The letter K for Intel or X for AMD indicates the chip is overclockable, while Intel also utilize the letter F to indicate a chip is without integrated graphics. For those of you looking to game on a dedicated GPU, basically everybody watching this video, you can happily save some money and pick up a chip that ends with the letter F. Now, CPUs have a few core metrics to consider. These are cores, threads, and clock speeds. The number of cores in a CPU indicates how many sort of mini CPUs are located within the chip. Back in the day, years and years ago, CPUs only had 1 core, meaning they could only do one thing at once. Now, with 4, 8, 12, or 16 cores, they can multitask and batch through loads of process applications in one go. For gaming, you want anywhere between 4 and 8 cores. I personally would rather vary towards at least 6, as I think that gives you an element of future-proofing. You also then have a thing called threads. This is very similar to core count, and pretty much all modern processors use a technology called hyperthreading, where the cores are actually able to articulate 2 tasks at once, essentially giving you virtual cores and even more multitasking prowess. The key thing to look for gaming is at least 4 cores, but preferably 6 or 8. Those of you looking to do video editing or high-end tasks may want even more cores still. Applications like DaVinci Resolve, Premiere Pro, After Effects will be able to utilize those much higher core counts. And those of you looking to live stream on Twitch, for example, may want to consider a chip with more cores. But cores are not everything. In fact, clock speed is arguably even more important. The clock speed indicates how many cycles that core can achieve within a second. A 5 GHz CPU can do 5 billion things per core per second. Now you can see there why a CPU with, in theory, 10 cores and a clock speed of 2.5 GHz would be exactly as powerful as a CPU with 5 cores and a clock speed of 5 GHz. Now, they're a very crude set of examples, so don't take them too seriously. But the main thing I'm trying to illustrate here is that the cores and the clock speeds need to be good. Modern, latest gen CPUs are actually hitting that 5 GHz mark and beyond, but for gaming you want 4 GHz or above. Obviously, the higher the better. Now that's all of the technical rundown on CPUs. Couple of other things to note. Some will include coolers on the lower end, which saves you money from having to buy an aftermarket unit, while AMD also recently offered their new range of X3D chips, where they basically stack the cache on top of each other to achieve a real nice edge in gaming. The best way to find a good CPU for a gaming PC within your budget is to look at the benchmarks, gaming and synthetic, and I'll link for all of the parts today, great resources at GeekaWhat.com, down in the description below. On the super low end, in terms of the i3 level, Intel tend to be your better bet, solely because AMD haven't released any cheap CPUs in years. I don't think they want to make Ryzen 3 chips nowadays. While moving up to the lower mid-range, and AMD's Ryzen 5 lineup are definitely worth considering. Don't discount their older generation Ryzen 5000, as it still delivers great performance, but with a bit of a price cut. Move through into the higher sort of mid-range bracket, and Intel's i5 13600K and AMD's Ryzen 5 7600X are worth considering, while on the high end you've got the pick of CPUs. A Ryzen 9 or i9 chip is sort of wasted for gaming and only really useful for those looking to do high-end video editing and intense tasks, while a little bit below that, something like the Ryzen 7 7800X3D would be my recommendation. So you've managed to learn a bit about CPUs and you're a bit closer to deciding on which chip to go for. Now you need to make sure you've got a motherboard that actually supports the processor. Now let's start with the basics. What is a motherboard? A motherboard basically provides all the connections and interfaces for your parts to interface and talk to one another. It's the structural backbone of a build. It provides the socket in which you'll be installing the CPU, the RAM DIMMs in which you'll be installing the memory, and the PCIe slots in which you'll be adding the graphics card into place. It also provides the basic fundamentals like your rear I/O connectivity, how many USB ports you have, what kind of Ethernet and Wi-Fi speeds, if any, are included, as well as handling all the important power delivery for the CPU and other components. Now, when it comes to picking a motherboard, it's actually not too tricky of a task. First, pick your CPU. That's going to have a massive bearing, as the AMD motherboards are different to the Intel motherboards. In fact, each new generation of CPUs will often command its own motherboard designs entirely. So head over to a site like PC Part Picker, add your CPU in, and it will show you only the motherboards that are compatible. Once you've done this, it's a good idea to narrow down your motherboard choice based on chipset. On the Intel side, you've got the B760 and B660 chipsets. These are the value-oriented, cheaper motherboard designs, with on the top end your Z790 chipset. For Intel, you'll need to pick up a Z790 board if you want to overclock the CPU, as their B-series chipsets don't support it. For any build under about $1,200, I would recommend looking at the cheaper B-series chipset. A cheaper motherboard will not impede on the performance, generally speaking, of your build. It's not going to bottleneck the graphics card or bottleneck the memory. You just won't be able to overclock the CPU or interface with your build on a set of USB ports that's quite as quick. On the AMD side, things are actually slightly more confusing and more simple at the same time. You've got their B-series chipset in terms of the B650 and B650E, while on the high end you have the X670 and X670E designs. When it comes to AMD, both sets of chipsets, the B and the X series, are overclocking friendly, and on the X lineup you'll just get that little bit more overclocking headroom for those enthusiast level high power CPUs. When it comes to the E suffix at the end of the chipset name, that indicates whether the motherboard does or does not support PCI Generation 5 for GPUs. That's the next gen GPU connector that none of the current lineup of cards are requiring. We're expecting this to become a requirement in 2024 and beyond. So if you're building a gaming PC for right now, don't worry about this too much unless you intend on a high power GPU upgrade a bit later. The main thing with the motherboard though is read some reviews and check the connectivity. If you need Wi-Fi for your system and you haven't got access to an Ethernet port, just get it, make it done with. And if you want high-speed USB-C and loads of connections for your 7 keyboards and 5,000 USB port setup racing sim, take that into account before buying the motherboard. Now, once you've got the motherboard and the CPU, you might want to think about some cooling for the CPU. As I mentioned earlier, cheaper CPU coolers from AMD and Intel will come with a thing called a stock cooler. This is a very, very basic CPU cooler that's only really good for the budget builds in the market. That means if you're assembling an i3 system with, I don't know, a 13 or 12100F and looking to spend $500 or $600, it can be a great inclusion. It saves you important money, allowing for more cash on your GPU and other core gaming components. But higher end chips do not come with stock coolers, and for good reason. They simply run too hot. And if you haven't got enough cooling for the CPU, you are going to introduce something called thermal throttling. Thermal throttling is a little bit like when you go for a run. If you've not got the right cooling for your run, you've not not got the right stamina, you've not trained yourself to the right level, your body forces you to slow down so you don't collapse in a big mess on the floor. And that's exactly the same with CPUs. There's a temperature that each modern CPU is sort of comfortable operating at, let's say 90-95 degrees Celsius. Hit that level or go beyond it, and the CPU has to slow down. It has to operate, it has to run more slowly, to use our analogy, in order to actually maintain, well, its operation full stop. The best way to notice thermal throttling is to open up Task Manager. Put your system into a game or a stress-heavy environment and look at the clock speed. If the clock speed starts to fall, you can see that the CPU is slowing down in a process called thermal throttling. But when it comes to picking a CPU cooler, there are so many options, and they are split into really two core categories: air cooling and liquid cooling. For the purpose of this video, I'll be looking at all-in-one, out-of-the-box liquid solutions. None of this custom loop malarkey, you can save that for another day. Air coolers dissipate heat through heat pipes and a tower of fins with a few fans on to help dissipate that air and cool that heatsink down, while liquid coolers use something called a water block and, of course, tubes full of liquid that run round into a radiator for more efficient heat dispersal. Air coolers are good for those of you looking to spend sub $1,000. Spend more than that and you'll want to look at a liquid cooler. Avoid 120ml liquid coolers, stick instead with 240, 280, 360 and, in extreme cases, 420ml AIOs. Brands like Corsair, Thermaltake, Deepcool, EK, GeekaWhat, Asus make great liquid coolers. Go ahead and take a look at those. You don't need to go for a radiator that's too big. Look at the reviews of your cooler, look at the TDP, the heat output of your CPU. As a general rule, a 240 for an i5 and some i7 tier CPUs, while a 360 for your Ryzen 7s and Ryzen 9s is where I would suggest looking. Of course, some coolers have the added benefit of bringing more fans and more airflow into the case, which can help to cool your other components too. With the cooler down, there's a couple more components I want to look at. Now, the next of these is the RAM and SSD. Let's begin with the RAM first of all, shall we? Now, when it comes to memory, you'll notice a key figure, this DDR5, DDR4, DDR3 designation. This essentially represents the memory generation of the RAM kit that you're buying. And deciding whether to go for a DDR4 or DDR5 kit is actually really easy. Depends on your CPU. The latest AMD and Intel generations support DDR5 memory, while the older last gen, the Intel 11th and earlier, and AMD Ryzen 5000 and earlier, only support DDR4. To complicate matters a little bit, Intel's latest 12th and 13th gens support both, and the kit you need to buy depends on the motherboard, as the DIMM slots are actually exclusive to DDR5 or DDR4. As a general rule of thumb though, I'd recommend a DDR5 kit. You want to make sure you've got 2 DIMMs or more for dual channel memory. Don't use one, and ideally don't populate your motherboard with all 4 DIMM slots just for aesthetic purposes, as this can hinder your upgrades later. 32GB is the recommended amount for me, with a speed of 6000 or above if possible. For more budget-oriented gaming builds, 16GB will suffice, but I cannot stress enough that if you're buying anything more powerful really than a 6650 XT, you want to put 32GB of RAM in a build. Once again, it's another place where you can easily create a bottleneck, and the prices of DDR4 and DDR5 memory in particular are now at rock bottom. They've fallen seriously fast in the last sort of 12 months or so. Moving through into storage next, and here you have 2 main options, an SSD or a hard drive. I'll make this super simple. Don't buy a hard drive, buy an SSD. Genuinely, if you're buying any modern graphics card from the last couple of years, you want an SSD. A hard drive's way too slow. It will be useful for mass storage, but make sure your Windows and your games and stuff are on an SSD. Now, this right here is a Gen 4 drive. You can also buy Gen 3, and there are new Gen 5 drives releasing. The difference is that the higher generation drives tend to be quicker. Gen 3 caps out at about 3GB a second, Gen 4 caps out at about 7GB a second, while Gen 5 caps out theoretically at about 14GB per second of potential bandwidth. For any gaming build really with up to a 4070 tier graphics card, you don't need anything faster than 4, 5, 6GB per second. But obviously, the more speed you can get, the better. Go for something with between 4 and 6GB per second of read speeds. The write speeds are less important, but still should be considered. And make sure you get a drive with at least 1TB of storage. Lower end builds can utilize a 500GB drive, but beware that game sizes nowadays are chunky. Motherboards do have room for multiple SSDs, but different slots may run at different speeds, so it's always a good idea to get as big a drive as you can afford. Some drives come with a heatsink and some come without. I would tend to recommend the drives without a heatsink personally, as the motherboard often has its own SSD cooling, meaning you can save a bit of money and make everything look aesthetically that little bit nicer. Moving through into the graphics card next, and this is the other major core component that you really want to consider when building a gaming PC. If you're really worried about this, stay tuned, as I'll be be covering my favourite GPUs and CPUs later in this video. When it comes to graphics cards, the market's in a really interesting place, with two major generations from AMD and Nvidia both on the boil. For Nvidia, you have the RTX 3000 and RTX 4000 series of cards, while AMD has their Radeon RX 6000 and Radeon RX 7000. Obviously, the newer generation, as a general rule of thumb, tends to be where you want to go for the latest up-to-date technology, but you shouldn't discount the older 3000 and 6000 series of cards. You aren't missing huge feature updates, and you're not going to be feeling like your card is obsolete. Instead, check benchmarks and buy the one that offers the best value in terms of frame rate. On the AMD and Nvidia sides, the higher the number, the better. So an RTX 4090 will be more powerful than an RTX 4070. I say better, I mean that in the sense of performance, not in the sense of you should buy the highest number graphics card possible, because it all depends on what you're trying to achieve. When it comes to the Nvidia side of things, they're 60 tier GPUs, so they're 2060 of years gone by, 3060 from the last gen, and upcoming 4060 from the current gen are going to be your 1080p card, while the 70 tier are your 1440p cards, and their 80 tier and above are your 4K gaming cards. GPUs have got so powerful nowadays that some of these cards can outperform even those expectations, but I would recommend those rough guidelines as far as resolutions go. Of course, as well, remember that games will get more demanding as years go on, and your graphics card might not always be able to punch to the high heights of 4K that it can nowadays once that new Cyberpunk, 3077 comes out with its huge hardware requirements. On the AMD side of the equation, a similar rule applies. Their 6600 or 7600 series will be for 1080p, while their 67 and 7700 are 1440p cards, and their 68 and 7800 and above are your 4K GPUs. A massive thing to bear in mind with graphics cards right now, though, is VRAM. It seems like manufacturers are making a bit of a mess of it, and including peculiar levels of VRAM in their cards. We'd recommend for 1080p you'll want at least 8GB of VRAM, but it's becoming fast accepted in the PC gaming world that 10 or 12 gigs is simply preferable. New cards need all that VRAM, and with ray tracing for both AMD and Nvidia becoming better than ever, that VRAM capacity is even more important. Once AMD and Nvidia have made their graphics cards, they then sell the boards to companies like MSI, Asus, GeekaWhat, ASRock, Palette, Zotac, Inno3D, XFX, you get the gist. These are what we call board partners. They will take the boards sold to them by AMD and Nvidia and add their own cooling solutions and memory on top to make their own graphics cards. It's just worth bearing in mind that the cooler you buy for your GPU is important, but isn't necessarily mission critical. And really, actually, sometimes the better value coolers are the better shout. That's because often the most expensive GPU cooler options out there end up costing so much, they're too close to the next tier of GPU to be necessitated as good value. In terms of productivity applications, it doesn't really make too much difference between AMD and Nvidia. Our video editors here prefer to edit on Nvidia cards due to the dual AV1 encoders on their new 40 series, but it really depends on your use case, and is about how much these cards are going to sell for. The most important thing with a GPU, though, is to read reviews, check benchmarks, look at the copious number of graphs out there from ourselves and others to check that the frame rate marries up with what you'd expect. And beware that GPU pricing can be volatile. It's not necessarily the best idea to buy the current gen GPU. It might actually be a better idea to buy last gen's card at a bargain basement price and get, in return, more VRAM, or just more money left in your wallet when the day is done. I'm next going to move on to power and finish with the case, and you'll see why that is in a moment. The power supply basically is the component that takes the power from your wall and turns it into what I call a computer-friendly format. Now, this is because all of the components in your build will have their own power connectors. The GPU has its own power connectors, the CPU has some on the top left of the motherboard has its own, and any drives, any SATA hard drives, SATA SSDs, or RGB controllers have their own power connections too. In order to determine what power supply you need, there's a few key steps that you can engage. The first is get your build put together on PC Part Picker, and then you'll see a total wattage figure. But don't use that solely to buy the power supply. You want to add at least 20 or 30% of headroom onto this figure to account for PSU efficiency and room for overclocking and future upgrades. Once you've got this figure, then head over to your GPU manufacturer manufacturer's website and look at the recommended minimum power supply wattage for the card you're going to buy. If that figure is higher than the one you've derived from PC Part Picker, always go with the higher number. It's better to have more power than not quite enough. Power supplies have a few key metrics to consider. The first is size. Most come in a standard ATX form factor, but you do get SFX form factor power supplies as well, standing for small form factor, if you've got a smaller form factor case. If you have, you'll probably know about it. Most people then will want an ATX power supply. PSUs also then have a different kind of interface. This can range from non-modular to semi-modular to fully modular. A non-modular interface basically has all the cables you could ever need jammed on in there already. They're not removable, they're not particularly easy to tidy or organize either. These tend to be the cheaper power supplies. Semi-modular power supplies will plug in connections like the CPU, motherboard, and maybe GPU power too from the off, but give you an interface where you can add extra SATA, extra GPU, and extra CPU power as you need. This is a good in-between, but the preferential power supply format to go for really is fully modular. This is where you have a full interface that allows you to only plug in the cables you need. It's also better for swapping cables out if there's a problem, and easier to cable manage. It's also worth considering that there are a new format of power supplies out called ATX3 power supplies, delivering the next generation of PSU technology, and most of these include the new PCIe Gen 5 power connector, but both AMD and Nvidia are set to utilize on their latest GPUs. It's less of a concern if you've got an AMD card, but if you're opting for an Nvidia GPU, certainly look for an ATX3 power supply to remove the need for these horrible dongles and centralize everything into one cable. The other major thing to think about with power supplies is their efficiency rating. Typically, this is done by a company called 80 Plus, but can also be done more recently by a company called Cybernetics. These companies look to evaluate how efficient a power supply is. 80 Plus, white, bronze, silver, and gold are your levels of efficiency, but they also range through into like platinum and titanium, and if I put this scale on your screen now, you can see that higher is better. Essentially, the more regal and posh the colour, the more efficient the power supply is. I'd recommend nowadays for budget builds at least an 80 Plus bronze, and for any system over about $1,200 or $1,500, an 80 Plus gold. Most PSUs should be 80 Plus gold or the Cybernetics equivalent in order to be a worthwhile bet. Stick with a reputable brand for your power supply. Don't go too overboard on the wattage, but certainly don't use this as an area to scrimp out the most value you possibly can. Moving through then into the case, and this is the final component to mention. I'll also be looking at some accessories in a moment which are worth considering. Now the case is basically pretty self-explanatory. It's the case that holds all of your parts. In order to pick a case, obviously you want one that looks nice, but first please consider a few key factors. It has to fit the CPU cooler and the GPU and the motherboard. Now motherboards are in different sizes, so you've got ITX, Micro ATX, AATX, and EATX, smallest to largest, and your case will list in the specifications section which size motherboard it supports. If you're building a small form factor system, you'll want to go for a case with that ITX motherboard support, while the budget builds tend to be Micro ATX and so on and so forth. As a general rule of thumb, an ATX case will support smaller Micro ATX and mini ITX motherboards, but quite why you would want to do that wouldn't make much sense to me, but it's worth mentioning. The graphics card is also an important factor. Does it support the right GPU length, especially with these large form factor next-gen graphics cards? You can check that in the case specs too. And does it support your CPU cooler? Either the height of your CPU air cooler, as in how far it sticks out from the motherboard, or the radiator size of your all-in-one liquid-cooled solution. Beyond that, have a look for ones with good airflow and a good number of included fans. Check reviews for build quality and make sure it's got the I/O ports you want. This might include USB-C, USB 3, headphone and mic jack, that kind of thing. Some cases may be worth the added cost if they include things like RGB fans and RGB controllers, which you were going to add later anyway, so have a look at this. And you may want to go for a case that's in keeping with your build. Let's say, for example, you've got a Corsair power supply and a Corsair cooler. You may also want to go for a Corsair case to keep everything nicely tied in together. If you're going for a white case, bear in mind that white components can be harder to find than their black alternatives. The main thing really though is to go for a case that matches your aesthetic, but keep in mind those factors about clearance, airflow, and cooling. There are a couple of accessories you might want to consider adding into your build. We like a cheap set of custom sleeved cable extensions for a nice aesthetic edge, but additions like more RGB fans for aesthetics and cooling, and vertical GPU brackets or GPU supports are also worth a bit of a look in. There are some really gimmicky PC hardware accessories out there though, so we would advise you to proceed with caution when filling your Amazon basket with too many extras that you probably don't need. So James, you've talked me through all the components. What if I just want to have, a good CPU and GPU combo to get me started? Get these two parts right, and it's much easier easier then to pick a motherboard, some cooling solutions, etc, etc. This is the area really where things can basically go very wrong. Now, as mentioned earlier, on the budget end, the Intel Core i5-13400F would be my choice. It's best paired up with something like an AMD RX 6600 or 6600 XT for entry-level 1080p gaming that doesn't break the bank. Got more money to spend than the i5-13400F or Ryzen 5 5600X would be where I would consider. AMD's 5600X is a great value sort of lower mid-range CPU right now, and I'll link everything mentioned today down below. It will pair up really nicely with the likes of a 6650 XT or alternatively an RTX 3060. The 6650 XT is the better card in this case though, so only go for the 3060 if you definitely want an Nvidia card for whatever reason. Move through the spending brackets up to something like an i5-13600K or Ryzen 5 7600X, and here you'll want to look at options like the RTX 3060 Ti or AMD 6750 XT. The 6750 XT is once again the better value option for straight rasterization, while the 3060 Ti a little tight on VRAM, even if it is a personal GPU favourite of mine for its valiant performance over the last couple of years. Move through the spectrum even higher and you can still stick with these i5 and Ryzen 5 tier latest gen CPUs and opt for something like an RTX 4070 or AMD RX 6800 XT. Either card will suffice, but the 4070 will be better for next gen features than the AMD 6800 XT, the better value option in this combo. Move through into the high end and you really are laden with so many options that it's difficult to recommend anything in particular. I'd avoid AMD's 7900 XT as their 7900 XTX or last gen 6950 XT are simply a better shout, while Nvidia's 4070 Ti is also a hard pass for me. This is a card that is too constrained by too many factors to really be worthwhile, with Nvidia's own 4080 and 4090 being a better pick for those of you with pretty endless wallets. I hope you enjoyed today's video. I know there's a lot of detail in there, and I'll link loads of useful assets for GeekaWhat.com with all of our wide range of benchmarks down in the description below. Thank you for watching though, and as always, we'll see you in the next one.